Okay, so on this one where you have an equation and you have denominators with variables in them, or even without variables in them, first thing we want to do is determine what the least common denominator is. All right. Well, to do that, you have to factor your denominators. Well, these denominators are as factored as they're going to get. So I have a factor of y minus 6 and another factor of y plus 2. So, um, so I need the y minus 6 and the y plus 2. And that's going to be my least common denominator, which means so that's step one. Step two is multiply both sides of the equation by the least common denominator. Now, this next step is going to be kind of long-winded, all right, but it'll make it easier for you to tell what's going on. All right, so we're going to get y minus 1 over y minus 6. I'm going to change the color times the LCD that we're multiplying through. Whoops, that goes there. Okay. Then we get that plus 1, and that's a new term, so it also gets multiplied by the LCD. A lot of people skip this step because, like I said, it's tedious, but if you see it, it makes it so much easier to tell what the heck is going on. So I'll include that at least once. Okay. Okay, so we got that. Now, the whole point of multiplying everything by the LCD is to get rid of the denominators, to rewrite the equation so there are no fractions. So at this point, all denominators should cancel away. Okay, so that we are left with y minus 1, y plus 2. Okay, that takes care of those guys. Then we've got that right there, which is just, I don't really need the 1 at this point. Okay, then on the right side of the equation, I'm just left with these guys here who did not get canceled away. Okay, so now we've got an equation, no fractions. Yeehaw! Okay, so now it's time to multiply these out, and these out, and these out. All right, so if you multiply them out the long, correct way, we'll get y squared plus 1y minus 2. And then when I multiply these out, I get plus y squared minus 4y minus 12. And then when I multiply these out, y squared minus 5y minus 6. Okay, now it's time to, I guess let's combine the like terms on the left side of the equation. Okay, so that'll give us, we'll get 2y squared on the left minus 3y minus 14, and then the right didn't change. Okay, let's see. 1 second here. Just use the mouse. Okay, so now we're gonna get all of this stuff onto the other side. We just need to get everything on one side. So I will subtract away the y squared from both sides, and I get y squared on the left. I'll add 5y to both sides, so that I end up with a plus 2y on the left. And then I'll add 6 to both sides, so I end up with a minus 8 on the left. Okay, cool. Now I could do quadratic formula or factor it. I'm just going to factor it because this one factors nicely. So we'll get a plus 4 and a minus 2. Right, set each factor equal to 0. And we get 2 and negative 4 for our answers. Now, because in the original problem, there were variables in the denominators. I really ought to check my work. Some things are going to be out of bounds and not work. For example, I know that you can't divide by 0, so 6 isn't going to work. If I plug in 6 for all of my y's, it's going to make it so that that denominator is 0. That's out of bounds. So I know that y cannot equal 6. And by the same token, y cannot be -2. Now, neither of our solutions coincide with those answers, so they should both work, but we really ought to check them anyway. But if either of our answers was 6 or -2, they'd automatically be kicked out. So you have to remember to check this and to check your work. So I'm going to go and check my work right now on the calculator. I just need to remember how to get there. Okay, yeah, I got this. And I think I better do some erasing. Okay, so then I'll make a fancy fraction. X minus 1 over x minus 6. And I believe it was +1. Yes, and then y plus 1 over y plus 2. Excuse me. Okay, so there's those guys. Let's go to the table and see how it looks. So my answers were 2. Let's see if I remember. Yeah, 2 and -4, I think. So when x is 2, yep, the left side and the right side of the equation, they match. So 2 really is an answer. How about -4? When x is -4, yep, the left side and the right side of the equation match. So they are both solutions. Okay. Anyway, so I know I got it right. Sorry, I know we got it right. All right, so now we can let's see how we can solve an equation that can be written in quadratic form. Okay. One way to do this is to recognize that you can use the quadratic formula on any trinomial as long as this exponent is double that one. Doesn't matter what it is, as long as it's double. Well, it is. Okay, well now normally, we've got a 2 there, and we got a 1 there that's not explicitly written. And then we just say, okay, x equals, negative b plus or minus the square root of b squared over, or minus 4ac over 2a. All right. So that's normally what we do. And we usually have just x to the first power right there. Why? Because that's normally what we have right here is x to the first, but that's not what we have on this problem. This problem, we have x squared. So we're going to do x squared. So you're going to put right here whatever the x to the smaller power is. Okay. That's really the only difference. That's about it. So now we'll say, all right, so x squared equals 17 plus or minus, we got a 2. I think it's 289 if I recall correctly. And minus 64, I suppose. Okay, so that'll give us x squared is 17 plus or minus the square root of 225 over 2, I think. Yeah, 2. Okay. Well, we're in luck. Square root of 225 is a nice, neat integer, 15. Okay, so then we can say 17 plus 15 is 32. And 17 minus 15 is 2. And we get 16 and 1. But we're not done because we haven't finished solving for x. Okay, we need to get that 2 away from it by doing the square root. And so remember, when you square both sides of an equation, you get the positive and the negative answer. And that makes sense because the highest power of the variable was 4. And so we expect 4 answers. So 4, -4, 1, and -1. And that's how we do it. This one will be done very similarly. You'll notice that you have y squared minus 11 raised to the second power and y squared minus 11 raised to the first power. And this power is exactly double this one. Therefore, we can do quadratic formula on it if we would like. And we'd say, all right, well, what's being raised to the first power? Well, y squared minus 11. So instead of an x squared on the left side of the equation, it'll be y squared minus 11. And then you do your, negative b plus or minus the square root of b squared minus 4 a. Oh, and this guy, we need to add 25 to both sides, get everything on one side. Sorry about that. That'll give us a positive 25 on the left side over 2 times a. Okay, so where a is 1, b is -10, and c is going to be that positive 25 when we get it over onto the left side. Okay, and then you would just tidy it up, and then once you get this all simplified, you'll add 11 to both sides and then take the square root of everything. So that's kind of how that goes. Now, an alternative method to this one would be to say, you know what, let's just multiply this all out, bring the 25 over, and then we'll have, and then start combining like terms, and then it'll be like the last problem where you have y to the 4th, y is second, and a constant term. You could do that, but that would be extra work that I'm guessing you're not going to want to do. I know I don't. All right, here's another one of that same ilk where the exponent on the first x is 1. It's just implicit. And square root of x, we've learned in the past, is the same thing as x to the 1/2. So this is actually x to the 1/2 power. And that 1/2 is half of this exponent. So we can do quadratic formula on this and say, all right, well, whatever this one with the smaller exponent is, that's what goes on the left side of the equation when I do the quadratic formula. And then I get -b plus or minus the square root of b squared minus 4. And then a is 1. And then c is 6 over 2a. And that would be the setup. And then you just, kind of run through it and everything's wonderful. And maybe we should just do that. I'll just do it. Okay, so that'll give us 5 and 2 and 25 minus 24. Oh, that makes it easier. Cool. All right, so then that gives us square root of x is 5 plus or minus 1 over 2, because it'll be the square root of 1, which is 1. So then that gives us 5 plus 1 is 6. And then over 2 is 3. And 5 minus 1 is 4. Over 2 is 2. So then at this point, we are going to square everything to get that square root off the x. And we get 9 and 4. And it's always good to check our work. Let's see if 9 and 4 actually do work. Because, well, things pop up sometimes. So x minus 5, x plus 6. Whoops. Hit that right arrow to get out of the radical. Okay, the other side of the equation was 0. And let's see if 4 and 9 make it so that the left and right sides match. And when x is 4, the left and right sides do match. So 4 is the solution. And 9, same thing. They match. So it really does work. How wonderful and glorious.